these are the solutions to the circular trigonometry test we did a few weeks ago. Alright, so what we do in question 1, we convert radians to degrees. Okay, so there's a formula for it. It's 180 on pi or pi on 180. I can never remember which one, but I just use the unit circle and work out what it needs to be. Okay, so I've got pi on 6. Now, if I draw up a quick unit circle over here, try to do it as best I can with a stylus. Okay, pi on 6, this is pi here. Okay, this is 0 degrees here. So what we've got is 180 here. Okay, and the 180 is being split, or pi has been split into 6 parts. 6 parts means that each of these degrees from 180 must be 180 divided by 6, which means each of them must be 30 degrees. So this one here is 30 degrees. Okay, you could also use that, or do that using the formula. So pi on 6 multiplied by 180 on pi once, and 30 times cancel equals 30 degrees as well. So I prefer my unit circle method, but this will just be the sort of feed the formula and get the answer kind of approach. Alright, this one here, now again from experience you should start to be aware that on 3 means 60 degrees. Okay, so that's what I think when I think on 3, I think 60 degrees. Alright, so we're going 2 pi on 3 in the negative direction. Okay, so on 3 means 60, so we're going to go 60 degrees from there to there. Okay, that's 2 lots of 60 degrees in the negative direction. 2 lots of 60 degrees means 2 lots of 60 means negative 120 or 240. Either of them are the same. Prefer to give it in the positive, but it was fine if you gave it in the negative. Okay, again you'll get that by just feeding it to 180 on pi, or multiplying by 180 on pi and getting the answer. Right, 8 pi on 2 is the same as 4 pi. Okay, and 4 pi, there's pi, 2 pi, 3 pi, 4 pi. So that's twice around the unit circle. That's 2 lots of 360 degrees. So that one there is 720. Okay, 7 pi on 9. Now on 9 is not a typical one that we see because it's not one of the ones that we know for exact values. Okay, so on 9 basically means if I've got pi being 180 degrees, that means it is 180 split into 9 parts. That means each part is 20 degrees. Okay, and this is 7 lots of 20 degrees, means that this is 140 degrees. A lot of you will find this one easy to run the formula on. 180 on pi cancels out. We've got 120, 7 lots of 20 equals 140. Alright, down here we're going to convert the following degrees to radians. Okay, so again, need my unit circle for this. 90 degrees is up here. Okay, this is pi. This is 0, this must be pi on 2, so equals pi on 2. But again, you could use the formula, 90 multiplied by pi on 180 equals 90 pi on 180, when simplified is just pi on, not 4, on 2. Okay, 225, well that's 45 past 180, okay? 45 degrees past 180, okay? So let's, now I just know that 45 is a quarter, okay? So 1 quarter to here, 2 quarters, 3 quarters, 4 quarters, this is 5 quarters. 5 pi on 4, 225 multiplied by pi on 180, and 225 pi on 180, which will simplify down to 5 pi on 4. And you can see why I like my method better, because I really don't want to simplify that. Alright, so we're going to do some exact values now. Okay, so again, anytime I do exact values, I've got the unit circle, but I've also got my triangle identities. So the 2, 2, 2 equilateral means that's 30, that's 60, that's root 3, and that's 1 from there to there. Okay, so that's my first one. The second triangle identity is not that way, it's this way I draw it. 45, 1, 1 and root 2. Alright, so sine of 30, we're going to go equals, so 30 is there. Sine is opposite over hypotenuse, equals half. Okay, cos of pi. Okay, so cos of pi is here. Alright, this is going to hit the x-axis here at -1, so this is just -1. Alright, 5 pi on 4. Okay, so let's think about where we are in the unit circle first of all. Okay, 5 pi on 4, well, on 4 means 45. Okay, so there's 45, 90, 135, 180. We're here. Okay, so we're actually at cos 225. Okay, now what I know is cos will hit the x-axis at a negative value there, and we're going to go negative cos of 45. So basically we're going to get this one here, work out what this is, and then negate the result, which will give us this one here. So we go to this triangle identity here and run cos on it, is adjacent on hypotenuse, equals 1 on root 2, or negative rather, 1 on root 2, or you could rationalise the denominator, which is root 2 on 2. Alright, here we go, we've got tan 5 pi on 2. Okay, so let's just work out where we are. So on 2 means 90 degrees. Okay, and let's have a look at this. 4 pi on 2 is the same as 2 pi. That's back to where we started. So this is 5 pi on 2. We're actually up here. This is the same as the tan of, and you can see I like to work in degrees. Okay, this is the tan of 90 degrees. Now remember, the definition of tangent is a line that runs at perpendicular to 0 degrees, okay, or at a tangent to 0 degrees. Okay, so we're talking about this line here, and we're looking or thinking about where this will hit the tangent, okay, and it won't, okay, because they are parallel lines, so therefore this is undefined. Okay, alright, cos of 150. Okay, I'm just going to redraw my unit circle here. Okay, 150 is here, approximately. Okay, now that means that from 150 I've got another 30 more to get to 180. Okay, or 60 to get back to 90, but I go forward there. Okay, so that means that the cos is going to hit at a negative. Okay, now that means it's going to be negative, and let's get the equivalent first quadrant angle. That's over here. That'll be 30 over here. So it's the negative cos of 30. Okay, so the cos of 30 is the adjacent over the hypotenuse, which is negative root 3 on 2. Alright, tan of negative 315. Alright, so negative 315. So we're going in the negative direction around here, okay, and 315 is 45 less than 360. So this is actually the same as the tan of 45. Okay, now that's this angle here, and we're working out where it's going to hit the tangent, and tan of 45 is actually 1 over 1, okay, which equals 1. Okay, sine of negative 300. Don't know why that's coming up with control there. What is going on there? Alright, you're just going to have to deal with my cursor saying control, because I don't know why it's doing it. Alright, sine of negative 300. Alright, we're going to go negative 300, which is 60 less than 360. So sine of negative 300 is the same as, right, the sine of 60. Okay, and the sine of 60, if we use a triangle identities, whoops, where's the triangle identities? Okay, the sine of 60 is opposite over, what's sine? Opposite over hypotenuse, root 3 on 2. Keep scrolling, stop scrolling out there. So this one is root 3 on 2. Alright, so we've got tan of 3 pi on 4. Okay, so here's pi on 4, 2 pi on 4, 3 pi on 4. So it's basically doing the tan of 45 more than 90, which is the tan of 135. Alright, now the tan is going to hit the tangent at a negative number. So I know this is going to be negative, and we're going to do the tan of 45 here. That's the negative tan of 45. We worked that out earlier. Tan of 45 is 1. This is going to be negative 1. Alright, sorry about the scrolling. It's my computer's doing funny stuff. What's going on? Okay, here we go. Alright, sine of negative 7 pi on 6. Okay, again, let's go unit circle. Now, 6 pi on 6 is pi. Alright, so 6 pi on 6 will take us here. This is 7 pi on 6, okay, which is a little bit more than 6 pi on 6 in the negative direction. Okay, now I know on 6 means 30. Okay, so this is 30 more than there. Okay, now think about sine here. It's going to be positive, so let's just grab the sine of 30 and we get this one. So this will be a half. Okay, because the sine of 30 according to the triangle identities is a half. Okay, cos of negative 26 pi on 3. Alright, well I know that 24 pi on 3, so let's just go 24 pi on 3 equals 8 pi. Equals 8 pi. Alright, so 8 pi means that's 4 lots of 2 pi. So basically we're going in the negative direction once, twice, 3, and then a 4th time. Now we're basically going in the negative direction 2 pi on 3 further than that, okay, because that's 24 pi. So on 3 means 60 degrees, so we're going to go 60, 120 more. Okay, so 120 more basically puts us, so 60 less than here will take us to 300, and then here, which is 240. So we're going to go cos of 240. Alright, now what's the cosine there? The cosine is negative. Okay, now let's just draw this in. This is 270, this is 240. Okay, so 240 to 180 is 60 degrees. Alright, so let's get the equivalent first quadrant angle, which is also 60 degrees. I'm going to go negative cos of 60. Right, the negative cos of 60 then is negative, let's go have a look at the identities. I think it's 1 on 2, but I can never remember. 60 adjacent on hypotenuse, it is 1 over 2. So negative a half. Alright, here we go. We've got the best approximation here of 1.8 radians. Well, it's a tricky one, this one, because you're not allowed to use your calculator, and it'd be easy to do with the calculator, but what you've got to know is a key thing about radians. 1 radian equals roughly 57 degrees. Roughly. Okay? So 2 radians will be roughly, I don't know, let's go 120. Okay, this is a bit less than 120. Alright? Now, let's have a look at the unit circle and find out where 120 is. So here's 90. Here's maybe 120 somewhere here. And we're looking at where it would hit the y-axis. No, what are we doing, cos or sine? Sine, yeah. Okay, so we want to work out where it hits the y-axis, and it's close to 1. Okay, it's pretty close to 1. It's not exactly 1, but it's close to 1. So let's just see what the answers are. There's only one that's even remotely possible. It's that. Okay, it's too far off. No way, no way. It's not in the negative direction, so that's the only possible answer. Right, how many times will sine of x equal -1 over this domain between 0 and 4 pi? Okay, so here's 0, that's 2 pi, that's 4 pi. So we're basically working out how many times in 2 revolutions sine is -1. So where's sine -1? It's here. Okay, so in going around, we hit it once on the first time round and twice on the second time round. 2. Okay, Danny thinks the value of cos 2 pi on 3 is a positive number. Is he correct? Explain using a diagram. Unit circle. Right, pi on 3. On 3 is 60 degrees. Here's 60, here is 120. Okay, now we're talking about cos. Okay, cos is where it hits the x-axis. Where does it hit the x-axis? At a negative. Okay, so it's certainly not correct. Okay, so here's my diagram to support my answer. Is he correct? No. Cos is always negative in second quadrant. Okay, and justification wouldn't be using ASTC. Okay, that's not good enough to really say only sine is positive in the first quadrant. The diagram really needed to show that the cos will be negative there. Okay, so you can't really say, you know, all stations to Clayton means second quadrant. Sine is the only one that's positive. Okay, Jesse is thinking of an angle, theta. Sine of theta is less than 0 and tan of theta is less than 0. So what could theta be? Okay, the important thing is it's ANDed here, so both of these are negative. Okay, again, using the diagram. So where is tan negative? Tan is going to be negative in the second quadrant because it hits the tangent at a negative value, and it's also negative in the fourth quadrant. So it's here and here are the possibilities. Okay, now where's sine negative? Okay, sine is only negative in the fourth quadrant. Okay, of the 2 quadrants. Okay, in this quadrant here, the sine will be positive, so it must be in this quadrant here. Okay, because sine is negative. Okay, so take any angle here. For example, I don't know, let's just make that 300 for argument's sake. Sine will be negative, okay, and the tangent will be negative. Okay, so there's my diagram to support it. And state the values theta could be. So theta can be less than 3 pi on 2, greater than rather than 3 pi on 2. There's 3 pi on 2 there, and 2 pi is here, less than 2 pi. Okay, so this basically says theta must be greater than 3 pi on 2 and less than 2 pi. Now you can't have the equal to as well, because remember sine is, tan rather, is undefined there, so that doesn't meet the requirements in that case. And also 2 pi can't be included because tan there will be 0, and the sine will also be 0, and we want less than 0 in each of these cases. Alright, so this last one here, there's a couple of different ways to do this question here. I know that the sine of theta equals -1 on 2, and the cos of theta equals -√3 on 2. So what's the value of tan theta? Well, there's a formula. Tan theta equals sine theta over cos theta, which means I've got -1 on 2 over -√3 on 2, which is negative divided by negative will be a positive, so we're going to do 1 on 2 divided by √3 on 2, which is the same as 1 on 2 times 2 on √3. They cancel out. Answer is 1 on the √3 or √3 on 3. That's the first method you could do it in. The second one is your knowledge of exact values. Okay, so sine of theta equals -1/2. Well, sine is only the value of half at 30 degrees. Okay, now you think about when would sine be negative, okay, or -30, negative a half, it's going to be in the third quadrant. Okay, so in the third quadrant here will be where the sign will be negative. Okay, just there. Alright, so I know that the angle we're talking about actually is 90, 180 plus 30. We're talking about 210. Okay, so we're doing basically the tan of 210. So we want the tan of 210. It's going to be positive, because that's where it's going to hit the tangent, somewhere positive. And we're talking about 30 degrees. Okay, so if we just get the tan of 30, we should get that answer there. Alright, let's go to our triangle identities on the previous page. So we're doing the tan of, what was it? 30. Tan is opposite over adjacent, 1 on root 3. So tan of 30 is 1 on root 3, or root 3 on 3, okay, which is exactly the same answer. Alright, so there's the solutions. See me if you think there's some issues there or you've got any problems. Be only too happy to answer them.